Good morning students. Once again I welcome you all in this online class of science. And students, as you know, we are discussing about motion and time. Yes, and we have discussed about the types of motion, about the time, how to measure time, the formula of calculating speed, the fast speed and slow speed, all these things we have discussed in the previous lesson, as well as we have discussed about the simple pendulum and the time period of pendulum, the oscillations, that is the to and fro motion of pendulum, the bob from the one extreme position to other extreme position. And in an activity we will be discussing about how to calculate the time period of a pendulum. Now in continuity to that, today we will discuss about units of time and speed. The basic unit of time is seconds. Yes, you must have seen the second hand in the clocks. Right. The larger units of time are minutes and hours, etc., etc. So these are the units of time. The smallest one, the basic, is second, and the largest one is hours. Now the basic unit of speed, it is meter per second, and the larger unit is kilometer per hour. When we see the average of our vehicles, we see kilometers per hour. Yes, because the larger areas covered by the vehicle we calculate. And if we are seeing the speed of a small object, then we see it in meter per second. Now there are many devices which were used in ancient times for measuring the time. In the previous lesson we discussed about the modern devices, the digital clocks and watches. Now here we will discuss about the ancient time measuring devices. Now these are sundials, water clocks, sand clocks. You must have seen these sand clocks in nowadays also in offices. Right. They look very nice, and how it works is there are two columns in this sand clock. One of these is filled with sand, and when it is kept upside down, it is having a small opening from which the sand comes down in the other column. So till the sand comes completely to the next column, they calculate it as a span of time. Like suppose it's 1 hour. If I assume it's 1 hour, so means the time taken by that sand going from one column to other is 1 hour. So if I am finishing my work, I have a target of completing it in 1 hour. I will keep the sand clock, and this way I will be seeing the time. Okay. These devices, the water clocks, in this the water comes down and the time is same way it is calculated as in the sand clock. Sundial, if you have seen in Jantar Mantar in Jaipur, the sundial is there. Here the time is seen by the sun's position. You know, sun is having different positions throughout the day. In the morning it is at one side, in the daytime, the afternoon, it is above our head, and again in the evening it is in one side. So according to the position of sun, the shadow is formed, right? Longer shadows in mornings and evenings, and the shorter one in the afternoons, noon time. So accordingly, the shadow of this in the sundial, a big dial is there, and according to the sun's position, the shadow keeps on changing, and we see the time accordingly. That is measuring time with the help of sundial. Like if the shadow is small one, it means it's the afternoon time, like this. Right. Now the next thing is measuring speed. In the previous class also I discussed about how to measure speed. That is total distance taken upon total time. So simply if I give you a numerical to solve, like here I have shown you few numericals, I will give you some more for practice for doing yourself. Like take this example, if a car is covering a distance of 100 kilometers in 2 hours, then the speed will be total distance, that is 100 kilometers, divided by total time, that is 2 hours. So the answer will be 50. It's very simple students. Just as we did the conversions in heat, same way, simply putting the values in the formula and you will get the answer. Fine. So this is how to measure speed. The formula, total distance upon total time. Now the next thing, okay, in the same way we can calculate from the same formula, we can calculate the time also. So if speed is distance upon time, the time will be distance upon speed, and the distance will be just interconverting the places of these in the formula. You know how to do the cross multiplication? Yes. For the distance, for the time, it will be distance upon speed. So if time we have to calculate, we will take the distance, that is 100 kilometers, and the speed, that is 50, we have calculated. So what time will come? 2 hours. As you already know the time, our answer is correct. Okay. So very simply, if you have the two things in your hand, you can calculate the third one by the single formula. Just by changing the places, you can have the formula for calculating distance and time also. Now the next thing is speedometer. Speedometer, it's a device which measures the speed of vehicles in kilometer per hour. You must have seen these speedometers in your vehicles. Yes, they measure the speed in kilometer per hour. Odometer, it is a device which measures the distance covered by vehicle. Now these picture which is shown on the screen, you must have seen in your vehicle these two. Correct? One is speedometer and the other one, it is including speedometer and odometer both. You must have seen. If not, then go and see today in whichever vehicle you have, two-wheeler or four-wheeler, you will see these speedometers and odometers over there. So they show us the total distance and the total speed. Right. Now the next thing is the distance time graph. Simply by taking two columns, in maths like you make the graph, same way here in science also we can do that. Taking the distance in one column and the time in the other column, and then matching the values, making the points and making the graph. More elaborately, we will discuss this in the live class. You all will sit with the graph papers and we will do this. Right. So, taking distance in one column and the graph on other, the time on other. If you have the values, like here the example is shown, time and distance. If this time is 1, distance is 1, taking the scale over here, we will make the pointers and then we will match them. If it is a straight line coming over here, it means the motion is uniform. Yes. And if it is irregular line, not a straight line, then it is a non-uniform motion. Okay. We'll do this and I'll give you the questions to do in your notebook for practice. Okay. In live class, just be ready with the graph papers. We'll be doing this. Okay. So that's it for now. Just go through all these topics and whichever doubts you have, just collect them all, jot them down and we'll discuss in live class. As well as we'll be doing this simple pendulum activity and this distance time graph also in the live class. Till the next time, thank you and have a great day.